Hey guys, it's me, Mr. Miller. We're doing our energy notes. Here we go. Energy. Energy is defined as the ability to do work. So, if you don't have a lot of energy, then you obviously don't have a lot of ability to do the work that's being asked of you. So, the SI unit for energy is known as the joules, which is capital letter J. And that's pretty much how you abbreviate that. Energy exists in many forms. We will talk about some of those forms in this PowerPoint, but not all of them. So just keep that in mind. The forms that I'm showing you are just some of many that exist out there, but these are some of the big ones. Energy can be changed from one form to another, and energy cannot be created or destroyed. So all the energy we have is on the planet. It just can't be created or destroyed. It constantly changes from one form to another. So potential energy to kinetic energy and then back again. So we're not destroying it or creating it, just changing its form from one to the other. Now there are several forms of energy. Here's just a few that we're going to focus on. 1. Chemical energy. 2. Electrical energy. 3. Heat or thermal energy, which we've talked about. And finally electromagnetic, which is the fancy name, which includes sound and light energy. So first let's talk about chemical energy. Chemical energy is energy stored in chemical bonds. So as those chemical bonds are broken, that's when the energy is released. So when you go to eat food, your body takes in the food, and then immediately as it starts to digest it, we break it down, and that's when the energy is released. So things like carbs and proteins and sugars help fuel your body. Other forms of chemical energy include coal, which we burn for heat, wood, same thing, gasoline, which we burn in our cars for energy, batteries, matches, etc. are all examples of chemical energy. Plants taking sunlight and then converting it in terms of photosynthesis is also chemical energy. Okay. Next, electrical energy. Electrical energy is energy caused by the movement of electrical charges and current. So, pretty much anything that runs on electricity or batteries is considered electrical energy. Power lines have electrical energy flowing through it. Batteries have stored energy. Lighting within our houses, any appliance, all have electrical energy. Heat and thermal energy. So heat, thermal is another name for heat energy, is energy created by the motion of particles. We already talked about the motion of particles back in another chapter. We've learned that the higher the temperature, so as the temperature goes up, that means that particles are going to move faster. So since they're moving faster, that means they have more kinetic energy. And because they have more kinetic energy and they're moving faster, that means they have more thermal or heat energy. Which is why the ice cube is melting, because we're increasing the particles, making them move faster, therefore thermal energy is increasing. Electromagnetic energy, light and sound, is energy that travels through space in waves. So light and sound all travel in waves. The sun and stars are a powerful source of radiant or light energy here on Earth. Electromagnetic energy is also carried by other examples, such as X-rays, radio waves, microwaves, laser lights, anything that's sound, all that stuff is considered electromagnetic energy. Radios, that kind of stuff. Now, those energies we talked about can all nice and neatly be broken down into two kinds of energy, or two categories. 1, potential energy, and 2, kinetic, which I believe you already studied these in 5th grade. So potential and kinetic energy. Let's talk about kinetic energy, otherwise known as KE. It is energy that's due to the motion of objects. So anything that's in motion, as long as it's moving, it has kinetic energy. Now, kinetic energy depends on two things: the mass of the object, the speed of the object. I've given you an example down here. You can see a bowling alley. Let's take a look at the first picture. We're saying they're equal velocity, so they have equal speed. However, the bowling ball has a greater mass versus the golf ball there. So that means the bowling ball is going to have more kinetic energy. Larger mass, more kinetic energy. Smaller mass, like the golf ball, less kinetic energy. So when those two go down at equal speeds to hit the pins, the bowling ball is going to scatter them. The golf ball, though, probably isn't even going to cause the pin to even wobble at all, because it has hardly any kinetic energy there. Now, let's look at speed though. So look over at the other side. Alright, so you have two bowling balls that have the same mass, but one of them has less speed, the other has more speed. The one that has greater speed, assuming they have equal masses, has more kinetic energy. Less speed means less kinetic energy. Let's take a quick look at this video link that I have for you. Alright, today we've been talking about kinetic energy and how it depends on two things, mass and speed. And in this particular experiment, we're going to show how mass affects our kinetic energy. So we're going to start off with two different cars. The first car is this race car here, and it has a mass of 27.5 grams. I have a box of paper clips there, set at 30 centimeters, and I'm going to put the car on a ramp, and we're going to test it. And we're going to see how the mass affects the kinetic energy. So here we go, I'm going to drop it, and that pushes the paperclip box to just over 60 centimeters. So I'm going to pull this right back here, put it right about at the 30 centimeter mark, and now I'm going to use the different car. This car has a little bit larger mass, as you can see. We've increased this to 93.4 grams. And of course, let's see how that is going to affect kinetic energy. So I'm going to put it on the ramp, same spot, and let it go. And we take a look, and we're clear down here at like 76 centimeters. So, we now know that kinetic energy does depend on mass. The greater the mass, the more kinetic energy the object has. Alright, let's talk about how speed now can affect kinetic energy. So let's take this particular race car again. We're going to put it on the same ramp with the same setup, 30 centimeters. This particular ramp I already measured, and it's sitting approximately 6 centimeters off the table. So let's go ahead, take our car, put it on the ramp, and we're going to let it go. Okay. We've moved about 57.5 centimeters. So now let's move our paperclip box back to where we started, approximately 30 centimeters. This time we're going to increase the ramp height. So we're going to put some binders and notebooks here and increase it. And this time we should have greater speed, because now we've increased the height of the ramp to almost 11 centimeters. So here we go. Car on here. It's now higher, which means we should get more speed, and we should move that box further, thus proving that more speed equals more kinetic energy. Oh yeah, we now went clear down to about 82 centimeters, thus proving more speed equals more kinetic energy. Okay, so that basically sums up what I was just talking about. Now let's talk about potential energy. Potential energy is energy due to the position and the shape of an object. What do I mean by position and shape? Position means where is it located. So the higher up an object is sitting, the more potential energy it has. The bigger the shape, the larger the object is, the more potential energy it has also. So pretty much examples include anything that's a resting object has potential energy. So gravitational potential energy, GPE, is energy that's related to the height and the weight of the object. So here's some examples. You see a blue skier. He obviously is sitting higher up, but they both have the same weight. Because he is higher up, he has greater gravitational potential energy. Greater height, more GPE. Over on the right side, you see the green skier has more gravitational potential energy because he weighs more. Even though they're at the same height, more weight means you also have more GPE. Okay? So let's do a quick video link to show you an example of this one. Gravitational potential energy is energy that's related to the height and weight of an object. So let's take, first of all, two marbles. Two marbles that are the same weight, And we're going to drop them from two different heights to see if this is true. So let's take the first marble, and we're going to drop it from a height of approximately, 10 centimeters. Here we go. 1, 2, 3. Now I'm going to take the other marble with the same mass, and I'm going to drop it from clear up here at like 30 centimeters. And we're going to see the impact. Okay, as I zoom in over here, we can see the impact circle is much larger with the 30 centimeter drop versus the 10 centimeter drop. So yeah, height does make a difference in terms of the amount of gravitational potential energy. Higher you go, the more stored energy or potential energy you're going to have. Now, let's investigate an object with a different weight, but this time dropped from the same height. So we're going to take this little weight right here, and we're going to drop it from, let's say, a height of approximately, let's go with 15 centimeters. There it is. 1, 2, 3. Now, let's drop this weight. This is much bigger. Woo! Much bigger weight. We're going to drop this from the height of 15. Same height. Same height. Let's see the impact circle this time. As we zoom back in, we can see impact circle. This made a much bigger circle than this little one right there. So again, dropped from the same height, objects with different mass have more potential energy. So the greater the mass, the more potential energy it has from the same height. Okay, so that kind of sums up gravitational potential energy for us. So think roller coasters. The higher that first hill, the more gravitational potential energy you are going to have, meaning as it's converted over to kinetic energy, you're going to be going a lot faster at the bottom of the hill versus a roller coaster that has a small little hill. All right, and hopefully we can investigate that in this unit. Finally, elastic potential energy. Elastic potential energy is defined as energy related to an object's ability to be stretched or compressed. So anything that you can pull back and stretch or compress it is considered elastic potential energy. Examples include trampolines, bouncy balls, slingshots, catapults, springs, rubber bands, balloons, all things that you can stretch and will go back to its original position, or you can compress it and it will also go back to its original position. Those are examples of elastic potential energy. All right, that ends our notes, and I will see you soon.